to process probably, and that way people can rewatch the session afterwards if they want to. Okay, so can everyone see the two files on my screen now? There should be two files open here.
Yes.
Okay.
Yes.
So before actually going to Gephi, I thought it would be a good idea to show the two data files that I sent to Margarita and that she distributed, just to give you an idea of how your data should be structured before you put it into Gephi. Because there are certain things that you need to have in your files in order for it to work. So there are two CSV files here. One is a node list and one is an edge list. So the left file is the node list, the right file is the edge list. So these files are in CSV format. I'm not sure if everyone is familiar with this. CSV stands for comma separated values. And it's a very universal format. I think practically every database software like FileMaker and Access. Also Excel, they allow you to export your data in the CSV format. And it's, I find the easiest way to put your data into Gephi. Gephi also supports a kind of XML structure. So if you're familiar with XML, you can code your data in what's called the GEXF format. But yeah, I think CSV is the simplest way. And it's basically, it's like a kind of table format. Your columns are separated by commas. That's why it's called comma separated values. And so, yeah, that's how this is the format you can use to get your data into Gephi. So as you can see in the node list, so I took Harry Potter as an example because it's something most people are familiar with. So in the node list, you have our subjects. In this case, it's people, characters from the 4th Harry Potter book. And so they're listed here. The first column is the ID, which is just a random number. The ID column is mandatory for Gephi. Without an ID column, your data won't be imported. It doesn't work. So you need an ID column. This doesn't necessarily have to be a number. You can also use the names themselves. But we've heard a couple of times now that, well, if people have the same name, this can pose a problem, because then Gephi will think that these are two the same people. So for my data, I always use random numbers, identifiers as an ID, because this is much more straightforward for a computer. So that's the first column in your node list that you need. And then I have a column for the names in order to know which number corresponds to which person. And then I've added two attributes. These are not mandatory, but they tell you something more about your nodes. So in this case, it's the house, the Hogwarts house they were sorted into. And the affiliation is something based on the 4th book, if they're, for example, member of the Order of the Phoenix, or if they're a Death Eater, stuff like that. So it's additional information about your node. You could also add, for example, a column on gender, on age, whatever, stuff like that, whatever you're interested in. The edge list then needs at least 4 types of information: source, target, weight, and type. And source and target are your start node and your end node. So these are the two nodes between which your edge or your relationship will be drawn. Now in undirected networks, it doesn't really matter which node is your source and which is your target, because there's no direction, there's no flow of information in your network, so they can be switched around. In a directed network, this is important. So the source node is, for a directed network, is the node where your relationship starts, and your target node is where your relationship ends. So the arrow points from your source node to your target node. So for example, if person A writes a letter to person B, person A should be the source node and person B should be your target node. Then I also have a column weight. Like Margarita explained yesterday, you have the possibility of adding weights to your node. If you don't do this, you can just put 1 here, then the weight is the same for everyone. But in some cases, it may be interesting to add a weight to see which people are more closely connected. Then the type is simply to tell Gephi if your network is directed or undirected. So in this case, undirected. So those are the 4 principal columns that you need in an edge list. And then I added a 5th one, an edge attribute. Again, this is not mandatory, but so you can kind of define edges this way. So you can define relationships between people. In this case, for example, one of the relationship categories is family. If people are related on the basis of a family relation, then it says family. If people have a tie because they're both in Dumbledore's army, then it's defined as Dumbledore's army. So that way. So yeah, so this is basically what a pretty simple node list and edge lists look like. So I'll open Gephi now, and then we can start playing around with it. There. So when you open Gephi, you always get this pop-up, which shows you your most recent projects. You can choose a new project. It also has some sample files, which if you open them, and they have tutorials on their website that explain functionality of Gephi based on these sample files. So this can also be interesting because I won't be able to cover all aspects of Gephi here today. So if you're interested in playing around with it a little more, it could be worthwhile to use one of the sample files and have a look at their website and their tutorials there. But so for now, we're going to choose a new project. And well, you'll see that whatever tab you choose above here, these 3 tabs, everything will be blank because there's no data in there yet. So these are the 3 main tabs in Gephi. Your overview tab will probably be your most important tab because this is where in the middle your visualization will be drawn. This is where you can tweak the appearance of your network. You can change the color or the size of your nodes. I'll show you how to do that later. You can choose a layout algorithm. Here is where you run your statistics. So there's some things here you already see that Margarita explained yesterday, like degree, density, stuff like that. We'll go into that later as well. You can filter your network here as well. And I also have this plugin, which is called the multi-mode network, which is really interesting when you, like I do, work with relational databases, because it allows you to convert your networks from 2-mode to 1-mode. But I'm afraid we're not going to have time for that today. But so there is a possibility of doing that as well. But first, before we can start playing around, we need to put our data in Gephi, of course. And for that, you need to go to the data lab. It's the 2nd tab at the top here. And this is just basically a kind of Excel layout, as you'll see when we import the data. it may be interesting to know that you can add data manually in Gephi. So here you have a button Add Node, where you can just type a label for the node and then it will enter, and then you can add edges. But this is, of course, very time consuming. It may be worthwhile if you just want to experiment a bit with a small network, but I wouldn't advise to do this if you're really working on something large or whatever, because well, Gephi is good for visualizing networks, but it's not that you can do much more with it. And I think normally if you're working on a project, you'd like a database that's not just geared towards networks, but other things as well. So yeah. So to import our data, we will use the Import Spreadsheet button here. So if you click on it, you get a pop-up to where you can choose your files, and we'll start with the node list. And you get this pop-up with a series of presets that you kind of have to go through first. First of all, normally if you've used the ID column and the name column, Gephi will automatically recognize this file as a nodes table, as you can see here. Also important is your separator. So most CSV files use a comma to separate columns. There are some computers that use a semicolon. So if your data is not nicely structured in columns, as it is here, but is all stuck together, then it might be that you have to change your separator. But yeah, it's just good to know. Then if you click on Next, you get an overview of the columns that you would like to import. ID is standard, you can't change anything about that. But the other columns, you can, if necessary, change what type of data is in there. But since name, house, and affiliation are all just strings, so text fields, this is correct, so you don't need to change anything here. There's also this option for time representation, but since we're not doing anything with time here now, you can ignore this. But if you're working with dynamic networks, which is a little more advanced and something, unfortunately, I can't cover here today either, you can change your time representation here. And then if you click on Finish, you get your import report. It says no issue found, which is good. But there are some things you have to look at here before you click on OK. First of all, your graph type is the standard setting for Gephi is mixed, but we have an undirected network here, so it's important that you select undirected in this case. You can leave auto scale checked. This is generally, it determines whether your nodes will be sized on the basis of settings that you will determine later in the overview, or if you have a separate column in your node list that defines your node size. If that's not the case, you just leave auto scale on. And I always leave the create missing nodes button on as well, because you never know that you import edges and you missed the node for some reason or another, and then at least Gephi automatically creates an extra node for that. Self loops, you can only check this box if your network is directed. So you can't have self loops in an undirected network. So a self loop means that a node is connected to itself. For example, if we use the network of names that Mark showed earlier, you can have self loops in that network because it is, for example, possible that a father names his son after himself. So someone who is called Horus, son of Horus, in a network of names, Horus will have a self loop then. But since we're working with an undirected network, you can't check it here. Then the edges merge strategy is also pretty important because it determines what happens if you have multiple edges between the same nodes. So, for example, if you have a network of letters, people writing letters to each other, if people write multiple letters to each other, you will have multiple edges. Or in the case of the network we have here, for some people, I've defined different types of relationships. So people can have a relationship because they are in the same house, the same Hogwarts house, but at the same time also have a relationship because they're also both in Dumbledore's army, for example. So in that case, you have to choose a merge strategy. I usually choose don't merge because if you do merge your edges, and you have assigned attributes to those edges, you lose that information. Because as you can see, the other options is like sum or average, minimum, maximum. So then Gephi either pushes them all together and then you lose your attribute information, or it chooses one of the multiple edges and only the attribute assigned to that edge is kept. So depending on your relationships, what type of relationships you have, you have to choose a strategy here. But in this case, I think don't merge is the best strategy. And then very important, so again, the default setting for Gephi is to add your data to a new workspace. You can see here on the top, you have workspace tabs. So you can open different networks in the same window, but we want to append it to the existing workspace, to workspace 1, of course, because we want all our data to be in the same workspace. So then if you click on OK, you will see that your data, your node list at least, is now in Gephi. You have your ID column here, the names, the house, and the affiliation. Now, an important step maybe to do now already is to fill in your label column, because if you don't do this, you won't be able to add labels to your visualization. And this is very easy. We'll be using the names of our nodes. And there's a very easy way to do this. Gephi has here this button, copy data to other column. So if you click on it, you can choose which column you want to copy. We want the name column, and here it says copy to label, which is what we want. So if you click on OK, then your names will also show up in the label column, and this will be used for your visualizations. Okay, so now we can import our edge list. So for this, again, we choose imports spreadsheet. You choose the edge table. And again, you get this pop-up. Again, you can see that Gephi has automatically interpreted this as an edge table because it detected a source, a target, a weight, and a type column. So if we go to next, then again, you'll see here the data types. So source and target are automatically interpreted by Gephi. Weight is set to double. This does not mean that your values in weight are multiplied by 2. Double is just a way, it's a term used to denote decimals. So you can just leave it as double. And then relation is, again, it's just a text field, so a string, so this is fine. And then if you click on finish here, you now see that our import report says parallel edges detected, remember to use a merge strategy. So in this data set, we have multiple edges between the same nodes. Like I said, I usually use the don't merge strategy, so we're going to leave it at this here. Very important here is to say append to existing workspace, because if you don't, it'll create a new workspace and then your nodes will be in one workspace, your edges will be in another workspace, and you won't be able to draw a network because there's no link between the data. So very important not to forget. And then if you click on OK, well, since you're still in your nodes table, you won't really see a difference. But if you go here to the edges button up here, you click that, you'll get your edge list, and then you'll see your source, your target, your type columns. Weight is over here in relation. And you'll see that Gephi automatically enters an edge ID. So ID is not a mandatory column in your data file, but Gephi does automatically add it for you. So now that our data is in Gephi, we can go to the overview pane, and now you'll see that you have a graph visualization in the middle. This is a completely random layout. So Gephi just places the nodes wherever. As you can see, it doesn't really give us much information. All the nodes are the same color, all the edges are the same color, the nodes are the same size, and it looks kind of messy. So this is where you can start playing around to try to see structure in your network, and also, of course, apply some statistics, which could be interesting. But before we do that, I'll just explain what the buttons here around the canvas are all for, or most of them. You may notice that if you're following along, that it's not very easy to zoom in Gephi. It takes some practice to play around with this, especially if you're using a trackpad on a laptop. This can be a bit annoying. Luckily, there's this button here, the magnifying glass. So if you kind of lose yourself, you can just click on it and it centers on the network again. Trust me, it's a very useful feature while you're using Gephi. These 4 buttons here are kind of like take me back to default settings. So the magnifying glass kind of like zooms out and centers your network again. This button is, as you can see, it says reset colors. So if you've been playing around with the colors in your network, if you click on it, everything just turns gray again, and you can start over with a new canvas. The same here, label color. We haven't added any labels yet, but so it resets the label colors, and here also for label visibility. So perhaps for your labels, to show them, you have here this black T. So if you click on it, you get your labels. Now, of course, this is very, very messy. Everything's packed over on top of each other. You can play around with, this is edge size, with your label size here with this slider. And you can also, here you can define like the font family and the size of the font you want. You can play around with it here. And here you can say, I want a fixed size for my nodes, I want it to be scaled, or I want it to correspond to the node size. Now, since all nodes are the same size here, all labels will be the same size as well. But I'm just going to select it already because later when I show you how to size your nodes, then you'll see that the label size changes along with it. This slider here allows you to determine the thickness of your edges. Could be interesting if you want them to be more or less visible. And this T here, if you click it, you will get your edge labels. But since we haven't defined any edge labels in this example, you won't really see anything. But if you do, the button is here. And then finally here you have the option to take screenshots of your network, which may be interesting while you're working. If you want to take screenshots of different stages, you can do that there. So yeah, first let's perhaps look at the statistics tab. It's pretty straightforward. Luckily with Gephi, you don't need to know the math behind. Well, you need to understand what the different statistics are, of course, but you don't need to do all the math yourself. So to calculate different network properties, all you have to do is click on the button, run. So Gephi has a whole range of statistics you can calculate. I'll just go over them one by one, perhaps. So average degree is the average degree of your network. So as Margarita explained yesterday, degree is simply how many ties does a node have. And the average degree is the average for the whole network. But by running average degree, you also calculate the degree for each individual node. So if you click run, you get a pop-up. You get the average degree up here, which is 8.7 almost. So that's on average, a node has more than 8 ties in this network. But you also get a nice chart that shows the degree distribution, which can be pretty useful. You also have the option of calculating average weighted degree. If you have a weighted network, it takes the weight of the nodes into account, but in this case, it's exactly the same. Network diameter actually combines several different features. So if you click on the run button, you'll see that it doesn't only calculate the network diameter, so the average distance between all nodes, but it also calculates some other centrality measures other than degree. In particular, between the centrality, closeness centrality, and eccentricity. So these are things Margarita explained in her presentation yesterday, and I think she was going to share her PowerPoint. So if you're not sure what all these things are anymore, you can always go back to her PowerPoint. We've already defined our network as undirected, so Gaffy has automatically selected undirected here. And then there's also the option to normalize your results, which means that you get a result between 0 and 1, which is useful if you want to compare networks, but it's not necessarily necessary to select this. It depends on what you want to do with the results. So if you click on OK, again, you get this report by Gephi. You see that your network diameter is 7 in this case. So the farthest path between two nodes is 7 hops. The average path length is 2.7. So on average, it takes 2.7 hops to get from one node to the other. And then here you get your results for betweenness centrality, closeness centrality, harmonic closeness centrality, which I must confess I don't know what that is. It's something new, and eccentricity. So these are values for each node. Maybe it's also interesting to note that when you calculate these statistics, they are automatically added to your data lab. So if you go back to your data lab now and to your nodes table, you'll see that there are a lot of extra columns here by now. And so for each node, you get the degree, the weighted degree, which is the same in this case, and the other centrality measures here. And then you can also sort these columns. So you see that Harry has the highest degree here, followed by Hermione and Dumbledore. And there's a very lonely node here at the bottom. Poor Stan Shunpike. He isn't connected to anyone in the network, unfortunately. Yeah, then so for the other statistics, you have graph density. All you have to choose here is whether it's directed or undirected, which Gephi has already done. Again, you get this report for the density of the graph. I find that in itself, the density of a single graph doesn't really say much. I think it's particularly useful if you have different networks to compare density between them. Then hits. I must confess that this is also something that I am not familiar with, not something I've used yet. It calculates something called authority and something called hub. There's more information about all this on the Gephi website, also about which algorithms they use to calculate these measures. As we've seen yesterday as well, there's a lot of discussion going on, especially in the community of historical network analysis, which centrality measures are useful for historical data. Yeah, it's interesting not only to check out the Gaffy website to see how they calculate these things, but there's also the historical network research website. I think it was shared in the chat yesterday. They have a very extensive bibliography section, which also includes papers on these issues of centrality and how to apply centrality to historical data. So if you're planning on doing network analysis and you want to use centrality measures, I would really go check that out to see what other people have done and what are the pitfalls of centrality when working with historical data. So again, well, it's the basic run. You get the results in your graphs. But like I said, I don't really know what hits is, to be honest. Modularity then is the term Gephi uses for community detection. Again, this has been touched upon yesterday, but also Mark showed the network of the Fayum toponyms earlier this morning, and those communities were defined on the basis of Gephi's modularity algorithm. And Gephi uses the Louvain algorithm, which is what Margarita explained yesterday. Again, it could be useful to look at some literature about this algorithm to see whether it's the best algorithm for your network. Like Margarita said, for especially large networks, there may be some issues with this algorithm. But my experience is that for the networks I've done, it's pretty accurate. So yeah. Here you can play around with the settings. Randomize is mostly, as it says here, has mostly to do with computation time. You can choose if you want to use edge weight or not. And then resolution defines how large or how small your communities will be. And it's something that it's best that you kind of play around with so that you run the modularity algorithm a couple of times and just change the resolution to see differences in it. So yeah, 1 is the standard setting, but you can lower it to like 0.1 or 0.5 or increase it, and then you can kind of see how this changes the results in your network. But for now, we'll just leave it at 1 and run it. And then here, so Gephi then groups your nodes into what it calls modularity classes, but this is just another word for a community or a cluster. So yeah. PageRank then is Google's algorithm to rank websites. It doesn't really make sense to run PageRank here because it's designed for directed networks, not for undirected networks. So we're not going to do that. And then connected components is the statistics. In this case, it's not really useful, but I'll run it anyway. It calculates how many distinct components there are in your network. So meaning components that are not tied together. So in this case, it says that there are 2 components in your network. but judging by our screen, there's only one. But if you zoom out very, very far there, I'm going to put the labels. No, I'm going to put the labels back and a bit larger. So if you zoom out really, really far, normally we should, oh no, I lost him. So Stan Shunpike, the node we saw earlier here in the data lab, who doesn't have any connections, so with degree 0, he should be floating around somewhere in space here, but I can't really see him at the moment. And that's why you get a result of 2 in your connected components, because you have one big component here, and then Stan Shunpike is all by himself somewhere, but it seems that we lost him, the poor soul. Oh well. Okay, so that's what the connected component statistics does. Just a bit smaller. Then you have here some more statistics on clustering coefficients. So yeah, it says something about the embeddedness of your nodes, which you can calculate, and then eigenvector centrality is another centrality measure that you can calculate as well. And then here the dynamic network filters we won't be using because our network isn't dynamic. So dynamic is basically when you work with a timeline and well, you have changing features over time. So if you define time intervals in your data, then your node degree, for example, can change over time. The number of edges in your network can change over time. And then you can calculate some extra things here. But since this is not the case, we won't be doing that here. So now that we've calculated these statistics here, we can start playing around with the visualization itself. First of all, we'll look here at simply at the appearance of the nodes and edges. For nodes, you can change the color of the node here with the color palette. You can change the size of the node. You can change the color of the label. And you can change the size of the label. And there are different criteria for doing so for each of these categories. You can say, so now we're in the color section, and you can say, I want all my nodes to be the same color. Then you choose for a unique color. In this case, it's gray. You can change the color simply by clicking on this square and holding it, and then choose a different color. And then if you click on apply, oh no, it seems like we're in the edges. Sorry. So if we go to the nodes. Oh yeah, okay, yeah. So it changes the node color, but automatically also apparently the edge color is changed to be the same color as the node. But sometimes you might say, no, well, I want to define the color of my nodes on the basis of a particular attribute, and for that you can go to partition. And then if you click on the drop down, you'll see a long list. It has your the principal columns that you imported for your data in here, but also all the centrality measures that you calculate through statistics are also available here. So you can say, okay, I want to determine the color of my node on the basis of degree centrality. Then it automatically gives you all the different numbers of degrees. So you see that 11% of the network has a degree of 4, 10% has a degree of 5, and it automatically assigns colors. But again, you can change the color by clicking on the square and choosing your own color. one of the things that you can use is what I just explained before, modularity class. So this is actually the result of the community detection algorithm. So you can see that Gephi has discerned 6 communities in this network. They've all been assigned a different color. So if you say, okay, apply, then you'll see that the nodes are colored on the basis of the modularity class or the community they have been assigned to by Gephi. But you can also choose one of the attributes that you have in your that you put in your node list yourself. So here are the Hogwarts houses, for example. I've also added some extra categories, people who are not in Hogwarts, muggles, squibs, and people who we don't know. So if you apply this, then it changes the color according to the house people are filtered in. And then there's also ranking. This is basically kind of works more or less like a heat map or whatever. So again, you can choose any of the attributes you want and apply colors based on a kind of continuum. Same for node size. You can choose a unique ranking, which means all nodes are the same size, a unique size, sorry. Or you go for rank again, and again you can choose between all these different node attributes. In this case, the attributes that we've imported with our data are not present because you can't really size a node on the basis of a house, for example. You need numbers for this, of course. So for example, in this case, we'll just size the nodes on the basis of their degree. You can choose the minimum and the maximum size yourself. So in this case, the smallest nodes will have size 5, the largest node 60. And you can see that because before I set the label size to node size so that it corresponds to the node size, that your labels are automatically adapted to your node size. Like I said, you can also play around with the color and the size of your labels here. I wouldn't really advise coloring your nodes and your labels because, well, we can just do it, but then, I mean, you get a really, yeah, it's a bit too much, I think. But in some cases, it may be interesting, I don't know, to color your labels instead of your nodes. That depends on your type of graph. And then for the edges, basically the same. So in this case, the edges are automatically colored depending on the color of the node. I think it's the source node that defines your default color in Gephi. If you say, okay, no, this is just a bit too much color, I only want my nodes to be colored, then you can say, okay, for my edges, I'm just going to use the color gray, and yeah, that's a bit more neutral than having all those colors on your edges as well. But it's the same principle. If you want to color your edges, in this case, you only have one attribute. It's the attribute that we imported for our edge, which is relation. So basically, you could color your edges on the basis of the type of relationship between the nodes. But then here, of course, you have the issue that there are multiple edges between two nodes sometimes. And in this case, Gephi just randomly picks one of the two. So if two people have a relationship, have two relationships, so one because they're friends and one because they're in Dumbledore's army, well, Gephi can't assign two colors to an edge in a visualization, so it'll just pick one of the two. So if you have multiple edges, it doesn't really make sense to color them. But the possibility is there. Okay, so now apart from playing around with the color and size of the nodes, You'll probably also kind of want to change the layout of your network. Like I said, Gephi just starts with a random layout when you import your data. But one of the nice things about layout algorithms is that they can already reveal part of your network structure. If you click on the drop down, you'll see a whole list of layout possibilities. Most of these are actually algorithms that allow you to kind of tweak the layouts after running an actual layout algorithm. So contraction, expansion, label adjust, no overlap. So no overlap, if you run this, it just makes sure that your nodes aren't on top of each other. Label adjust, make sure that your labels don't overlap. And expand and contract, well, they expand and contract. So if you say contract my network with a scale of 0.8, your network becomes more dense. If you say expand my network, it becomes more sparse. You can expand it into infinity if you want. But these are not really actual layout algorithms that look at the structure of your network. For that, Gephi contains a couple of default algorithms. There's the Force Atlas and the more recent Force Atlas 2, Vruchterman-Reingold. You have random layout. So if you do random layout, again, you just get a random layout. In this case, useless with the labels. As you can see, the nodes are piled on top of each other. So you'll have to do no overlap to see something. But like I said, it's just random. And then there's Yifanhu. Vruchterman-Reingold is a layout that basically uses a circular layout. It stops after a few seconds, and then if we center on the graph again, we see that it uses kind of a circular layout, and the best connected nodes are put in the center, and the least connected nodes are pushed to the outside. So it already gives a kind of structure to your network, but it's always in this circular form. I find that if you're interested in detecting clusters in your network, that Force Atlas 2 and Yifanhu, I don't really know what the difference is between Yifanhu and Yifanhu proportional. I don't really use that one a lot. I usually use Force Atlas 2 because it's a network that really looks at, like I said, like clusters and communities in your network. So if you select the Force Atlas 2 option, here you get this whole list of settings that you can tweak. I think the most important ones are scaling and gravity, because it defines how close your nodes are put together or how far apart they're put. So if you click on run, I'm gonna remove the labels again. You'll immediately see that you get a whole different layout than we've had up until now. Force Atlas 2 keeps on running until you click stop, which is nice because it means you can play around with the settings while it's running and you can see them change immediately. So as you can see, our gravity is set to 1, which means the nodes are really, really close together in this case. So I'm just going to lower that to 0.5, which doesn't really do a lot, apparently. I'm just going to click on prevent overlap, and then you'll see, so there's already a function in Force Atlas 2 that allows you to pull your nodes apart so they don't overlap. So like I said, the stronger your gravity, the closer your nodes will be pulled together. Scaling is something you can play around with to push your nodes more apart. So the higher your scaling, for example, if we put this on 50, you'll see that your graph becomes more sparse. So these are settings you can play around with while the layout is running, and you can see things change at the same time. I'm going to stop the layout now and try to zoom in again.
Jan, maybe we can answer a couple of questions that were in the chat.
Oh, yeah. Okay, sure. Sorry, I don't see them because I'm sharing my screen.
Yeah, in fact, that's why I'm...
Okay.
So one was by Dirk that asked, how about the degree under dynamics? Is it also temporal? So there, yes. And the second is by Aryan that asked, how do we interpret the way Gaffy itself has identified communities?
Okay, so the degree under dynamic, it does indeed change. If you use a timeline in Gephi, well, I can't show it now because I don't have time intervals in my network. But if you use a timeline in Gephi, you can select the width of your time interval, so to say, and then when you slide over your timeline, it will the degree will change depending on which nodes appear and which edges appear and disappear in your network during these time slices. So it changes over time. So you can also I don't know, maybe if there's time later, I made a little video from a more extended Harry Potter network here that shows the changes of the network over time. So nodes appear, edges appear, nodes disappear, and edges disappear. And you can also see the sizes of the nodes, nodes growing bigger and smaller depending on edges appearing and disappearing in the network. So in that way, it is, yeah, it's dynamic. So it recalculates the degree for different steps in the timeline.
Okay, so but it has nothing to do with first or second degree networks based on...
No. That's something
okay,
different.
certain nodes.
Yeah.
Yeah, okay, thanks.
Mm-hmm. Yeah. And so the second question was, can you repeat it again, Margarita?
How do you interpret the way Gaffy itself has identified communities?
Yeah, so that's something I wanted to show. I wanted to show now. So here, as we've seen, I'll try to put the labels back. I'm going to put them, fixed size. So here I've, like I said, zooming in Gaffy is not very straightforward. We've colored the nodes here depending on their house, I think. No, I'm going to change it back to house. Oh no, these are the labels. Sorry. Yeah, so the nodes are colored depending on the house people, or what's the affiliation? Yeah, the house are in. And then if you compare this, or should I do affiliation? No, I'm going to do affiliation. So nodes are colored depending on the affiliation attribute. So this is an attribute that we imported with our nodes. So it's something that we assigned to the nodes ourselves. This is something that when running your community detection algorithm, Gephi ignores. So when defining communities, Gephi only looks at the relationships in your network. So it doesn't know that a person is part of Dumbledore's army when looking for communities, for example. But if you compare this, this color map to the one you get when you color them according to Modularity Class, you'll see that they're pretty similar. So Gephi kind of automatically detects these groups in your network just on the basis of the relationships. And that's what's interesting about this community detection feature, is that you can run it and then it kind of, it kind of demonstrates whether the communities that you think are meaningful are also present on the basis of the relationships as well. So you can see that, it kind of more or less corresponds to the affiliations we defined ourselves. So it's something that, like Mark showed with the place name network earlier, So if you're not really sure about an attribute of a node, so like with the place names network before, there are places, ancient places that we can locate, that we know where they are on the ground, and that we also know to which administrative region they belong. But there are also place names mentioned in ancient texts that we have no idea where they're situated. We don't have any archaeological remains that we can pinpoint a place name to, and that we also therefore don't really know to which administrative region they belong. But by using the community detection algorithm, they are assigned to a particular community. Like Mark showed before, there are place names that appear in a community with other place names that are all assigned to a specific region. And then you get this kind of probability that those place names that you can't locate are also part of that administrative region. So community detection can be useful in that respect, that it points you to a probability that a node belongs to, in this case for Harry Potter, for example, to a certain social group, or in the case of place names, to a certain administrative region. And it does this purely on the basis of the relationships in the network. So I don't know if that answers your question, more or less.
Yes, thank you.
Okay. Are there any more questions at this point? Because maybe I can see that there are only 10 minutes left, so maybe I can answer some questions. Maybe useful.
Not at the moment, so.
Okay.
I do have another question if no one else.
Sure, go ahead.
Yeah. So I was wondering, in the sense of practicality, where would you advise stopping adding information to the nodes? So, for instance, I'm thinking right away of all these aspects of the networks I would like to analyze in the coming years. And I'm thinking about time, locality, but also affiliations with particular schools, affiliations with Sufi orders, affiliation on the basis of family, the books they transmitted, the books they heard, the books they wrote, and is there sort of how should you limit the amount of information that you want to add, or is there basically no limit? Do you understand what I mean?
Yeah, well, there is no limit. You can add as much information to your node list as you want. If you think it could be interesting, you can add it. So if you already have the information in your database, I don't really see why you wouldn't add it if you think it's potentially useful, because it's no extra work, so to say. So yeah, no. So in that respect, there isn't really a limit in Gephi. It can handle a large amount of information, especially on the node level. On the edge level, I think, yeah, but then it's just basically how many edges. I think the largest network I ever made was, it was really big. I think it was up to 100,000 edges. That was pretty slow. Then Gephi is pretty slow. But Gephi can handle a lot of data, and especially attributes are not a problem. So yeah, if you have the information, then you can include it. Yeah.
Thank you. It's really amazing, actually, when you think about it. But I think it will be very time-consuming, right?
Yeah. Well, the most time-consuming part is collecting your data and making sure that it's structured and that it's because one of the things that that often happens. You think you have all your data, you think, yes, I'm ready to make my network. So you put it in Gephi, and then you start noticing all these mistakes in your data. You notice that your categories aren't all structured correctly, that there are spelling errors in one of your columns, which means that all of a sudden you have for example, order of the Phoenix and order of the Penix. So you have two separate categories there. And so a lot of work goes into cleaning up your data and until it's actually ready for your network. That's actually the most time consuming part, I think, curating, adding and curating your data.
Yes, thank you very much. A friend of mine is working on networks in Damascus of Muslim scholars in the 19th century. And one thing that's very interesting for our field of research is that in the 20th century, there's been this sort of movement to create a history of people of authority. And when you actually look at if you analyze the networks, based on the source material that we have from the biographical dictionaries, then it allows you many times to identify people who were apparently famous and big in their respective times, but in the 20th century they've sort of been forgotten and downplayed. And this is amazing, the things that you can do with this stuff.
Yeah, it is. Are there any more questions that I can answer now? Well, if not, then maybe for the last couple of minutes, I can just quickly show you the filter options, because that could also be useful. So here next to your statistics tab, you have your filter tab, and you can. There are a lot of options to filter your network. One of the most basic is, of course, depending on your attributes. If you open the attributes folder, you'll again see a lot of options. You have equal, which means that you filter on one particular attribute. And you'll see that all of the centrality measures and stuff that you calculated, that they are in the list. But to keep it easy, I'll just choose house. So if you say like, okay, this isn't a pretty small network, so it's not that hectic. But if you say now, okay, I just want to see people who are affiliated to a very particular house, you just go to equal under attributes and you drag the house setting to the filter query here. And then if you open it, you can click on parameters. And then here at the bottom, you see that you can enter a house. So if we say that, okay, I just want to see the people who are in Hufflepuff, you can type in Hufflepuff and then filter. Oh, no Hufflepuffs left. That's strange. Okay. So normally if you type in a house, you get the correct house. Let's try Muggle. Yeah, so for Muggles, we see that actually only Harry's aunt, uncle, and then Dudley and his other aunts, that they remain. So the rest of the network kind of disappears. So that's if you choose the equal filter.
I think Hufflepuff didn't work because you wrote it with only one F at the end. So
okay. Yeah, you have to be careful with typos. You also have the option to filter inter-edges. This basically means, again, if we choose house, for example, you can say, okay, I only want to see edges between people that, that only belong to Slytherin. And so I'm going to zoom out a bit. If you filter, then you see that here in the larger section, all the edges have disappeared, and only edges that start or end, like I said, Gephi zoom function, only edges that start or end with people who belong to Slytherin Maybe I should change the colors to the houses. Yeah. So Slytherin are the green nodes. Only those edges then remain in your network. For intra edges, you can say, okay, I just want to see edges between people from Slytherin and Ravenclaw, for example. So those are the green nodes and the blue nodes. So if you filter those, you'll see that only the edges between people who are in Slytherin and people who are in Ravenclaw remain. You can also combine filters. So in this case, for example, you only have the edges between Slytherin and Ravenclaw, but all the nodes are still present. If you say, I find that a bit messy, then you can add the equal filter to the query you already have here, and you do that by just dragging the second filter down here, and then or maybe it's better, yeah, and then no, because you can't select two houses here. Oh wait, yeah, here, partition, that's better. And then say, okay, I just want here in partition, I only want Slytherin and Ravenclaw. And then you only have the nodes belonging to Slytherin and Ravenclaw and the edges between nodes belonging to Slytherin or Ravenclaw. So yeah, this allows you to, if you're only interested in specific parts of your network, allows you to filter out background noise, so to say, and to focus only on specific areas or on specific nodes or on specific edges. Again, the dynamic tab is for dynamic networks, so I can't demonstrate that here. Edges is to filter on specific edge attributes. And you can also use operators, so not or intersections or whatever. So you can add those to your queries as well. So that's a way to focus on specific parts of your network. And I see that the time is more or less up now. So I'm just going to leave a couple of more minutes for questions, perhaps. Yeah, I think I've covered the basics now. So,
thank you very much. Actually, I have two questions.
Mm-hmm.
The first one is about the labels and filters. Is there a way to just have in the final visualization some of the labels that I select? Because I didn't find a way to do so. Like,
yeah, I know there is a way, but it's difficult. I know I've been struggling with this as well. I think you. I think first, for example, if you only want to show the labels of nodes with a certain degree size, so like the largest nodes, I think you first have to filter on degree range.
Yeah, then take off and re-put on the label thing. So
yeah, it's something like that, but it's because you have to nest your filters. It's kind of, sometimes you kind of have to experiment with which of the filters it executes first before the other. But I remember, because that's the problem that a lot of people struggle with, it's definitely something, I can't remember now how to do it exactly, but it's something that you can find on the Gephi forum. So that's also very useful. Gephi has this forum where you can ask questions, or you can just go check it out if you have questions and see if other people have asked them as well. It's a really good forum where you can find a lot of information about Gephi and about how to work with it. But yeah, the labels it's not very useful, because also here the third tab I haven't really explained it now, but this is like your preview tab. And the idea is that this is like the final network that you can export as an SVG or whatever. And here too, you only have the option show labels or don't show labels. So either all your nodes have labels or they don't. So it's not really useful. But so there is a workaround with the filters, but I can't remember exactly how it works again. Yeah.
Okay, I will look in the forum.
Yeah, sorry.
And then no, but because I had found some suggestion, but actually I didn't manage to solve it. So if you could show it quickly, but indeed it's a complicated thing.
Yeah.
Okay. And then sometimes so for searching for one node, like you have just in the network, I don't want to filter out all the others. I just want to find that one and then look at it in the just in the visualization. Is there a quick way to do so?
Well, I think you just need to use the name node here. So, and I think, yeah, so problem is that there's something wrong with I can't type anything. I don't know what this is. So normally you should be able to type in a name here, but I don't know why I can't select this field. I can use this, but I can't enter anything.
And
you
it's not going to filter.
Sorry, what?
It's not going to filter all the others out.
Yeah, that's true. It will probably filter everything else. No, there's not really like a search option or something here. So if you're working with really large networks, I think the easiest thing to do is to look for the node through the filter and then turn the filter off again once you found the node. But there's no such thing as indeed like searching for a node. That's something that, so the networks that Mark showed earlier that we exported through the Oxford plugin to show them online, there you do have a search filter, which is easy because there you can just like type the name and then the node is highlighted, but the rest remains visible on your screen. But here in Gephi itself, you don't really have that option. So yeah, if you're working with really large networks, it can be difficult to trace your nodes, yeah.
There is no way, like in going in the data laboratory, selecting my node, it will not stay highlighted. I was hoping that there was something.
No, I don't think so. No, not really, actually, no. Yeah, sorry.
Maybe if you make a PDF of it and then you go just Control F searching in the PDF and then you compare it with the Gephi, is that a possibility? Or
I haven't tried it. I haven't really used the PDF export. I usually use SVG or PNG. But yeah, it does require kind of a workaround, I guess. Yeah. So, but normally, yeah, I don't know why I can't enter anything here in the filter. Normally you should just be able to type in the name and then it will filter the node and you know where the node is, but yeah.
Okay, thank you.
Yeah.
Are there any other questions?
Well, maybe, Jan, you can say something about how difficult it is to go from a Gephi network to the online network.
Oh, okay, yeah. Yeah, so like Mark already showed, there is this a plugin to do so. So the thing is, of course, Gephi is good when working on networks yourself. But if you want to share this stuff with other people, well, you can't expect them to all upload your node list and your edge list in Gephi themselves and look at it. So one way is to take screenshots. So I already showed the screenshot button here below in your overview pane, and then you also have the preview pane where which is like your final network, so to speak, and where you can export different formats. But the downside of screenshots is, of course, that, well, first of all, they're static. So you can't really play around with them like you can in Gaffy. Plus, screenshots, when they're used, especially for publications, usually they're pretty small, so a lot of things aren't really visible. There's also the extra issue that a lot of journals only publish in black and white, so you can't really add color to your graphs and stuff like that. So to kind of solve this problem, the Oxford Internet Institute developed a plugin for Gephi that allows you to easily export your network in a JavaScript environment, and so you can put it online on a server. So basically the only thing you need is a server, which a lot of people don't have. So that is why at Trismegistus we have our TM network section where we publish these online networks. And so not just our own networks, but we've already published networks of other scholars who don't really have an environment to do so. And so basically what this plugin does is it puts your network in the right format, in the right files, into a particular folder, and all you have to do is put that folder online. So it's really, really easy. And the plugin feature in Gephi is available under Tools. So if you go to plugins there, these are my export plugins. You'll see here a whole list of plugins that you can use for Gephi. There are really a lot of them, and the one you need to export networks for an online environment is called Sigma Exporter. So if you install that one, you normally under File you get, I haven't installed it here on my laptop here, but you just get an extra option, export as Sigma network, and the computer, the plugin does it all for you, and you get this folder on your desktop that's ready to go. All you need to do is put it on the server. So that's pretty useful, and I don't know if I can show one of the networks. Well, Mark already did before, but so they're basic. You can't do as much as you can in Gephi, but they are in more or less interactive. So if you take the editor's network, for example, here you have the search function. So here you can just type in a name, and it automatically creates the ego network of that particular node. So it's pretty useful. And then you can hover over it to see the different nodes. If you click on another node, the information in the pane here changes. You see different centrality measures, the people that particular node is connected with. So it's pretty useful if you want to publish networks to make one of these online versions. You can use screenshots, of course, for your publications, but I find it really useful to add an online edition as well, because that way people can play around with your network a bit more, and yeah, it's a bit more dynamic than just a screenshot. So I think it's a really useful plugin for Gaffy. So yeah.
You publish on Trismegistus all kind of networks?
Mm-hmm. Yeah, wait.
Okay.
Yeah, so here, well, there are two types. So we have the section networks that were created specifically for papers in journals. And the database add-ons are the networks basically that Mark showed in his presentation. But so if you go to the Networks for Articles section here, you see a whole list of papers that were written that use network analysis. And then if you click on it, you're brought to the network in question as well. So like that.
Also papers that don't use Trismegistos data. Like
yeah. So here, like Anna Hetzberg, she has this prosopography of Memphis from the New Kingdom, which is much earlier than the period we focus on. And she created networks for that, but she had no online environment where to publish them, and so she asked if she could publish them on our website. So yeah, it's also possible. It doesn't have to be Trismegistos data, no.
Okay, thanks.
Yeah.
Are there any other questions? Okay, if there are no other questions, well, thank you very much, Jan, again from the presentation. And I think we can see each other. We can take a pause and see each other at 12 for the keynote speech by Bart. I don't know if anyone objects.
You're welcome.
Okay, then Jan,
yeah.
If you're curious, I can explain what HITS is.
Oh, okay, yeah, because it's something that wasn't there in the old version, and it just appeared, and I have no idea what it was, and I just ignored it.
I think that if it's the Hub Authority Score that I studied, which I think it is, it's something similar to PageRank. I think in the little bit the idea is that you are a good hub if you point to good authorities. So it's again for directed networks, and you're a good authority if you are pointed by good hubs. And how it does it is that for each node you attribute two scores, one hub and one authority score. You initialize them all at random at the beginning. And then you do various turns. So at the first turn, you sum, like your new hub score becomes the sum of your current hub score plus the authority scores of those you point to.
Okay.
And your new authority score becomes your current authority score plus the hub score of those who points toward you.
Okay, like that, yeah.
So at every turn, those that are pointed by many people will increase their authority, and so they reciprocally increase the hub, and at a certain point it should converge, I think, and get get score. So it's a little bit, and it was used indeed for ranking pages also.
Oh, okay, yeah. Okay, great, thanks. Yeah.
It's because I had to do an exercise in maths exactly on that, so I remember.
Okay, yeah. Yeah.
Okay.
Yeah, I think that's for a lot of people, that's like kind of the scary part about, well, not just Gephi, but anything with network analysis, is you have all these measures, and sometimes it's kind of difficult to understand what the difference is between them and which one is useful in which situation. So yeah.
I know that eigenvector is used, of course, the eigenvalues, but I don't know which one would be better between PageRank and this one for.
No, I'm not sure either. Yeah.
But this one also was generalized to the idea, and this also was very nice. And I think that, for instance, Neo4j implements this. That you can calculate a similarity score between nodes. So you can give a network model that simulates a kind of structure that you want. And then you can ask the software to calculate in your network which nodes are similar to each one of the nodes in the network. And then, you know, if there is like kind of, you want in between node or something like this. And it's a little bit, it's a generalization of this because there it's like if you are calculating the similarity to a network that is just formed by one source and one target node. So if you are similar to the source node, you are a good hub, and to the target node, you are a good authority. And
okay,
that can be pretty useful.
Yeah. Okay, cool. Okay.